Let's see how we can destroy humanity. So this is an introduction to machine learning agents. Or another title for it is How to Build Skynet. So my name is Ife. I'm a field engineer with Unity. So I visit studios, I look at projects, I help optimize projects, solve problems, get feedback from developers like yourself back to the team, and then conduct workshops and talk like this one. So in this presentation, I will show you how you can assemble a machine learning agent setup, and then how to identify ways that you can use machine learning in your projects and model your behavior for your autonomous agents. So GTA 5 here, who here plays GTA 5? Cool. It's one of my favorite games. Open world, you can do whatever you want, drive around, do silly things. So somebody used GTA 5 as the training environment for the agents, right? It's for their machine learning agents to train their driverless car. So it's very difficult to train cars with other cars, and then you have to avoid collision and damage and so on, right? But when you have a virtual environment that allows your agent to interact with other agents, then you can train them in a more cost-effective and safer way. But of course, the developer of GTA 5 wasn't very happy because it's not meant for that purpose. So Unity's machine learning agent interacts with the environment. We call this the reinforcement learning. So the agent decides on does an action, and this will changes a state in the environment, which will then give the reward to the agent, either a reward or penalty. So based on that, then agent will learn and improve on the action taken. So here you see the basic model of Unity's machine learning agent. So every agent will have a brain attached. And then the brain will be a child of an academy. And then there is an external communicator that then talks to an external library that does the machine learning process. And of course, that library will feed back to the academy, which will then let the brain decide what next action to take, and the agent will then act accordingly. So agents, they have unique sets of states, and they can have, and they will observe the environment, and they can take unique actions and also receive unique rewards. So the action is decided by the brain that is attached to the agent. So the brain will define the actual state and the action space that is available, and based on that, decides on the best action to take. So the brain currently supports 4 modes: external, internal, player, and heuristic. So external means the brain will let an external library or to decide on what's the best course of action to take. Internal will be you have a trained model that is imported or embedded into Unity, and then queries this model and decides what's the best action to take. Player, of course, is you allow the player to be controlling the brain, right? This is like you're the player and you're controlling this character. Heuristic will be the traditional hard-coded way where you have to hard-code the player's, the AI's behavior. So the interesting part here is the external and internal. So the academy will define the scope of the environment. So it will have an engine configuration where you can decide on the speed and rendering quality. So when you're training the agents, actually the quality is not that important. Later I'll show an example of how you can create an environment in Unity and use that as a training environment. And then frame skipping, what's the engine step to skip before you take the next decision. and also decide on the global episode length. So when this time is reached, then all agents will terminate its actions. And finally, the external communicator. So this will connect to collect all states and observation from the agents, and then pass it to a machine learning library, an external machine library. So, so I'm going to talk to you about TensorFlow today. Well, that's the library that we'll be using, but it's possible to use other libraries if you wish to. And Jay over there, I guess you guys have met him. He's here to support me. So if I said something wrong, I think he'll just shout out and correct me. So full disclosure, I'm not very familiar with machine learning. I'm just pretending to know. I'm also very new to machine learning, but I'm very interested in knowing more about machine learning and the potential that it can do. So here are some training scenarios that are available. So you can train a single agent. So a single agent will just decide on the action. You can have simultaneous single agents, which I'll show you later. So each agent is doing its own thing, and they are not relying on each other. There's no dependency there. They are just deciding the best action on their own. Right? There's also adversarial self-play. So there will be two agents, and they are playing against each other. So there will be an inverse reward. So like, for example, a chess game, right? So two agents will be playing against each other. So this is the model that Google's AlphaGo takes. So if you read the news, Google's AlphaGo managed to defeat a human player. So that's the first in history, and then they evolve AlphaGo with AlphaGo 0, and this new model, AlphaGo 0, can play against itself. So the old AlphaGo relies on human experience, and from there they learn, right? But the new AlphaGo 0 plays with itself. So there's no human bias there. So it's just learning the game on its own, and they find out creative ways to play Go. And it's a lot better than AlphaGo. AlphaGo 0 beats AlphaGo 100 times out of 100 times. Cooperative multi-agent. So this is like when you need the agents to be cooperating to achieve a goal. For example, maybe there's a puzzle game. So no one agent can complete the goal itself. So every agent needs to cooperate. For example, like an agent needs to stand on this side of the floor where there's a trigger. Another agent needs to go to the other side of the trigger, and then the door will open, for example. You need two agents to cooperate to progress, right? Another one will be competitive multi-agent. So this will be like every agent is competing against every other agents. Right? So for like, you can imagine a game like a free-for-all deathmatch, a first-person shooter free-for-all deathmatch. Right? Everyone for itself. And of course, there's ecosystem, where you can then define independent rewards for each of the agents. So you can imagine something like a city. So you have agents that will act as the pedestrians, agents that will act as the drivers, agents that will act as the police, for example, and then you have a whole ecosystem, each of the agents acting on their own with their own rewards and actions. So what do you need to get this running? It's not pretty. Right now, this is a beta, and it's very new. So a lot of processes are still very complicated to set up. But once you have this set up, the experience is satisfying. And the goal here is for us to integrate all these processes into Unity, so you don't have to rely on all these extra tools or setup. So first, you need Unity 2017.1 and above. Next, you need to download the project from GitHub. And that's the link. It includes all the necessary libraries, demos, and documentations. And you will need Python 2 or 3. And that's the link that will describe how you can install Python 2 or 3. And it is a super long URL, so I shortened that for you. You are welcome. So it's a very detailed description. Just follow step by step and you should get it running. But here I will highlight some things. So you would need CUDA Toolkit 8 with CUDNN 6, specifically 8 and 6. So there's a newer CUDA Toolkit 9 and there's a newer CUDNN version, but they don't work. You need specifically 8 and 6. So once you've installed CUDA Toolkit and CUDNN, you need to copy the content of CUDNN to the CUDA folder. And then you need to set up a CUDA home environment variable, point it to the CUDA folder. Then you have to edit the path environment variable to include the path to the CUDA library. There are 2 libraries there, and you have to include 2 of the paths there. And you have to install Anaconda 3.6 to configure Python environment. Once you're done with that step, now you have to fire up command prompt in Windows 10, create a Conda environment, and activate it. So these are the 2 commands that you would use: Conda create dash and TensorFlow dash GPU Python equals to 3.5.2. And to activate it, you to activate TensorFlow dash GPU. So once you've done that, you have to install TensorFlow. So you do pip install TensorFlow dash GPU. So up to this point, yes, there are a lot of steps, a lot of hoops to jump through. And we are not done yet. Next, open the project, the sample project that you got from GitHub. Open that with Unity. And there are some description from the GitHub that will let you know what configuration you will need to do, but I just shortened that. Just press build, and you should have a build. So next, because this is not the actual game, this is just the training environment, you will need to fire up Jupyter Notebook. And then through there, you train your agents in this Unity app with PPO, which is Proximal Policy Optimization. It's a algorithm, I think, algorithm for training. And once you're done, you can finally export the model out and embed that model into Unity. And remember when I mentioned the brain has 4 modes: internal, external, player, and heuristic. So external will allow you to train in TensorFlow. And then when you're ready, you have the model, the trained model, you will now switch the brain to internal, which it then reads from that model, the trained model, right? So, demo time. So before the talk, I've already did this step here, and you can see I'm currently still training the agent. It's still training the agent. Go away. No, not now. Okay, I'm still training the agent, and these are the results of the training. So I built an environment where it is a simple game of a simple game like this. So I'll show you now. So right now I'm using the player mode, so I can control this agent, right? So you see here there's a green cross and there's a red cross. The red cross is a penalty. The green plus sign, that's a reward. So the agent should go to the reward instead of the penalty, right? So for example, I can control this guy, move it to the reward, and then the game ends and start again. So that will give me 1 point. If I go to the cross, the penalty, then I will lose 1 point. And then the game will start over, right? So then machine learning, what happens is it will just train this agent to play this game over and over again until it reaches a point where you get more rewards than penalty, right? And there is also a setting there that will reduce your point gradually if you do not take an action soon. So this is to encourage the agent to decide on an action soon. Otherwise, you just dilly-dally there and just don't finish the game. So there will be gradually reducing its score to encourage it to take action fast, right? So here you see Grid Academy. So this is the academy that I mentioned, which has the scope of the environment. And then here you can see we can define the training configuration. So we are going to build this application out with a width of 80 pixel by 80 pixel. So it's a very small application because again, the rendering, the quality, and the look doesn't matter. We just want it to be running and simulate. And time scale here is set to 100. And over here, there are some default reset parameters. For example, I can define the grid size. Right now, the grid size is 3 by 3. You can make it a bigger grid size, then it become a lot harder for the agent to learn. But I've started with an easy 3 by 3. And number of cycles is just 1. So that red cross there, that's the penalty, that's only 1. You can define more, and also you can define more goals if you want to. The green plus sign here, number of goals, so also 1. And then under the academy, this is the brain. So this is the brain, and these are the settings here. So there's a brain type here. You see there's a drop-down brain type here. So currently this is set to player, but I can choose, if I want to start training this agent, I'll choose external, and then I'll build my app. So I'll go to File, Build Settings, and Build. So once you've built, then you can start command prompt. Command prompt, activate TensorFlow. So activate TensorFlow dash GPU. And now we are in, we have activated TensorFlow, and then we will need to use Jupyter Notebook, which looks like this. Which looks like, what was that? No, don't know. Which looks like, come on. Which looks like this. So it points to my document folder, and then I've placed my project here, ML Agents Master. So if I go into here and I see Python, so I go into Python, and I want to start this PPO training module. So then if I press on that, I get connection failed. Yeah, I was training. Okay, so this is the old version. I was training and connection failed. So this is the new version. So if I go to PPO, you'll see this. And these are the steps. So this is the first step that you need to run, and just press run. When this is done, you will see here, currently it says in bracket, and there's a 1 here, there's a number here. So this is not currently active. While it is running, that 1 will be an asterisk. So if you see the asterisk turning to a number, then that means this step is done. So when that step is done, you can proceed and select the next step and press run again. And then press the next step and run. So here I want to highlight this step here. You need to name your environment name to the application that you built. In this case, I've built my application and call it Skynet. Let me show you in documents here, environment. Wait, where is it? Python. There you go. So this is just a regular Unity application. I name it Skynet. And that is why you need to change the environment name here to match your application name, Skynet. So once you're done with this step, proceed to the next one to load the environment, which means to start Unity. So you would see a small pop-up appears. Oh, lost it. Let me see if I can start this up again. Okay, finished. I think I lost connection, so let me try to start this. Jupyter Notebook. No? Okay, so then I'll go to Documents, ML Agent, Python, and this guy. So I'll start the first step, run. And you see this is now an asterisk instead of a 1. So when you see the asterisk turns to an integer, that means this is done. So it's still running, still running, still running. It's taking a long time. Hang on. Oh, there you go. It's done. There. So it turned back to a 1. So when this step is done, I'll proceed to the next step, hit run, and this is done. I'll proceed to the next step to load the environment, and you will see here, the Unity application loaded. So it is a very, very small window. It's just 80 by 80. And next, you would have to start training the agent. So this is the actual step to train the agent, start running. And then you will see here, the game is now running. So the agent is currently playing the game, so over and over and over again. So here, after a while, you will see here, it will show you the result of the current score. So like I mentioned, if the agent proceeds to the green cross, you get 1 score. If it proceeds to the red, you get a -1 score. So when it plays over and over again, it tries to get a score that is above 0, right? A positive number. So then when you see the mean score get something that is more positive, then you can stop that training and there you go. So mean reward. So we've started with -0.06. So yeah, our agent is not very smart right now. It's getting a negative score. So as it plays, this score will improve. And the longer it plays, the better the score will be. Right? So once this is done and you're happy with the mean reward, you can proceed to the next step, which will then export the training to a model. And this will be this is what you will see. It's a bytes file. So again, Skynet, because I named it Skynet, so Skynet.byte. So then you can import this into Unity. Here, let me start Unity. Oh, I have it. That's weird. Okay. So here, I can change from external to now internal. Oh, I forgot to mention one more step. You will need to install a package, TensorFlow Sharp package, for this to work. And the link is available again in the GitHub page, so don't worry. So once I've changed this to internal, I will get this graph model slot here, and which I can then apply my Skynet model here. So let's see what happens if I apply my Skynet model. I've already imported my Skynet model here. Okay, I have my Skynet model here. Let's see if my Skynet is ready to destroy humanity. Okay, hit play and see how it does. Pretty smart, huh? So this ran for, I think, maybe 30 minutes to an hour, maybe, I forgot, but it's pretty good. I have another version here. So this is Skynet 1, version 1. This was trained for only a very short while, and let's see how it does. So cute. This is so cute, right? So, yeah, still not. Oh, there you go. Come on, Skynet, come on. There you go. So, yeah, so the longer it trains, the smarter it is. And this is trained for only a very short amount of time, so as you can see, it's very, very stupid. But you get an idea of how you can implement this with, let's say, adjusting different difficulty levels. So maybe if you know that your player is dominating the AI, you would use a better model, and then you'll be a challenge to the player. Or if the AI is too smart for the player, you can use a dumber model, and then it'll be a better experience for a player, right? So this is a single agent. It's just playing a game by itself, right? Let me show you another example. So this example here, we have multiple single agents. So each of these platforms, they will try to balance the ball, but they have no knowledge of the other platforms. They are just doing their own thing, right? But the training was performed such that each of these agents are trained at the same time. Okay, so let's see, I have this guy, Academy here, the brain here. So I'll change this to internal, and I'll assign the model. So again, I'll show you the dumb version. So this was simulated for about 30 minutes. So platforms are trying to balance the ball. So a couple of them failed. And it's very wobbly, some of them. Yeah. And let's see a better version. So this trained for I don't know how long, but it came with the example. So it's a lot more stable, as you can see. Like a lot of the platforms are just stationary. They know exactly that is the balance point. But still, there's about 2 of them are still wobbling. So the longer you train, the better they are. And if you want to know more, you could visit this site and can look at this YouTube video here. And also there's a link on more on machine learning. And thank you. So I hope you guys are ready to destroy humanity. And again, thank you for coming to my talk.